All right, we're going to get started with our earthquake chapter here. We're going to do the front page right now, and that'll be all we cover in this note session. I'm going to give you about a minute here to, in your own words at the top of the note sheet, I want you to jot down what you think an earthquake is. So when you hear the term earthquake, what do you think that is? Okay, so hopefully you've gotten yourself a little personal definition of what you think an earthquake is. I'm going to give you kind of a book definition, if you will. They are vibrations in the Earth's crust caused when rocks under stress shift suddenly along what is called a fault, which we'll talk about here in a moment, and giving off energy. Okay, so that's what we're looking at. So what does that really mean? We'll get this a little bit bigger here for you. Make it a little bit easier to see. That should, it's pretty big. How about we go about right there? All right, so vibrations in the Earth's crust caused when rocks under stress suddenly shift. So in other words, they break, right? They move and they give off energy. There's a lot of energy released from those rocks, break inside the Earth, and then there's movement along the Earth's surface that is passed out in what are called seismic waves that we will get to in a future section on the back page of your sheet here. Okay? So there are three different ways that a rock or a fault can be put under stress, okay? And those stresses, or maybe you want to think of these as like forces, okay? Those stresses are applied then to faults. So it's kind of like matching. We're going to match a stress up here, so example, a compression stress, and we're going to match that to, for example, a reverse fault, okay? All right, so a stress is pressure put on an area of the Earth's crust, okay, when the plates move. Okay, so pressure put on an area of the Earth's crust when the plates move. Okay, so these are the different types of pressures. Okay, so for example, we have compression. That's when the plates would be pushing towards each other. So this would be like taking your two hands, putting your palms together and just pushing as hard as you can at each end. Just pressing your hands together as hard as you can, right? That's compression stress. All right, that then relates to a reverse fault down here at the bottom. So this is caused from compressional stress. Okay. And that's going to cause the plates are pushed together and one plate is forced upward compared to the other plate. Okay, so again, like I said, we're going to match these together. So we've taken a compression stretch, which is again compressing or pushing something together. And those compression stresses cause a reverse fault when plates are pushed together. Okay, so we're going to take a quick look at that here. So this is what we're looking at right here, a reverse fault. It says in a reverse fault, the block above the fault moves up relative to the block below the fault. This fault motion is caused by compressional forces and results in shortening. A reverse fault is also called a thrust fault. Okay, So here's what's going to happen. So here we have one side of the fault. Here we have the other side of the fault. You notice right here is the fault. That's the crack in the earth. And if I start the animation, you see the arrows here are representing compression, and the blocks move in accordance to that. So you can see how this block moves up and over this rock because of the compression force. I'll do it once more here for you. Okay, the next one is a tension stress, and that's when the plates are pulling away from each other. Okay. Here, my best example for you would be to think of a rubber band, right? You take a rubber band, one hand on each end of the rubber band, and you pull it apart, right? You're putting tension on the rubber band, okay? That relates to a normal fault, So we're going to put tensional stresses here, okay? And in this blank, it says plates are pulled apart, and one plate moves downward compared to the other plate. So now we've got tension stress, again pulling the rubber band apart, creating a normal fault. Okay, so this would be this one right here. In a normal fault, the block above the fault line moves down in relative to the block below the fault. This fault motion is caused by tensional forces. Okay. So again, down below the animation, you're going to see the tension stress, and you're going to see the fault blocks move. Okay, so there's our downward motion. As you can see, we're pulling the rock apart, putting tensional force on it. And you get the downward motion. Okay, the third type is this shear force. Okay, so the stress we are putting on here, we would say that it is sliding or bending. Okay, and in this situation we get a strike-slip fault because we are putting shear stress on this fault line, and the movement we get is sideways. So you might be thinking back to the plate tectonics unit, because in plate tectonics we talked about transform boundaries that moved sideways. So strike-slip faults and transform boundaries are one and the same. They act in the same manner. They both move laterally or sideways, a sliding action, right? And a shear force is thinking like shears, like sheep shears, like you'd be cutting something, right? So you're literally like sliding the rocks past one another, and they break or bend as they move. And our animation for that one is right here. So we have a strike-slip fault. It says in a strike-slip fault, the movement of blocks along a fault is horizontal. If the block on the far side of the fault moves to the left, the fault is called a left lateral. If the block on the far side moves, it's called a right lateral. Okay? So you're going to notice on this one, instead of there being an upward and downward movement like there were with these two, you're going to want to look right here and pretend that this blue line right here is a sidewalk, okay, or a highway. So I want you to watch what happens to this sidewalk right here as we start the animation. You're going to see the lateral movement. You're going to see what happens to the sidewalk. Notice how it gets split in two. So you walk in here, and all of a sudden the sidewalk is over here because the earth literally slid sideways on the fault line here. So we're going to watch it once more, and you see that lateral movement happening, that sliding action. Okay, so that is as far as we're going to go with the note sheet here. So you should have an earthquake defined, and then you should be able to match your stresses up here to the type of fault down here. Again, it's matching, right? You're matching the stress to the fault.